Question we're going to look at right now is the type with a normal distribution given a data value or, in part B, a sample mean, find the probability. So let's look at the example and see why it's that type of question and then how to solve it. So the question, the lengths of lumber machine cuts are normally distributed with a mean of 90 inches and a standard deviation of 0.6 inch. So first part A, what's the probability that a randomly selected board cut by the machine has a length greater than 90.19 inches? Okay, so first of all, what is given in this problem? So in this problem, we know that the mean is 90. So we'll jot that down. Mu equals 90, and standard deviation is 0.6. Sigma equals 0.6. We're also told that it's a normal distribution. That's useful to know. And that's what's given. And then finally, the question is, what is the probability? And then in part A, they're asking specifically, find the probability that a selected board has a length greater than 90.19. So that's what they're asking. All right, so now so there's the given information. That's what they're asking. So we've already described the distribution, the mean, the standard deviation, and it's normal. And now we get to draw a picture. So what's the picture of this situation? It's a normal distribution. So 0's in the middle for Z. And then for X values, the mean is 90. And then the value of interest is 90.19. And they're asking about the probability greater than. So probability greater than is the area to the right. So that is the setup of the given information. And now we go to the next step, which is to do the calculation. So what's the first thing we have to calculate? First thing we have to calculate is this missing z-score. So what's the z-score? Z equals x minus mu over sigma. So the x value was 90.19. The mu was 90, and sigma was 0.6. So I'm going to grab my calculator. And let's see, there we go. 90.19 minus 90. Hold on. Okay. 90.19 minus 90 in parentheses divided by 0.6. There's my z-score. Okay. I can write down all those digits. I'll just use 4 digits to be overly careful. So 0.3167 if I round it. Okay. So now I've got my z-score. And I'm going to fill it in. Next, we calculate the area. The way we calculate the area is by using StatDisk. So I got StatDisk pulled up. I have it as an app. You can also use it on the web. Okay, so click Analysis, Probability Distribution. This is a normal distribution, so I'm using that. And what we have is a z-value. So I'm going to type in the z-value, 0.3167. I click Evaluate, and it tells me everything. Area left, area right, blah, blah, blah. The thing, of course, we're interested in is the area to the right, which was 0.3757. And area is your probability, so that is your final answer. Equals 0.3757. there's your final answer for part A. Okay, so next we take a look at part B. So part B says a sample of 39 boards is randomly selected. So this is already new information. So we still have mu equals 90, sigma equals 0.6, and it's normal, but now we have n equals 39. And as soon as you have a sample, and as soon as you have the n equals 39, what that means is it's a distribution of a sample mean. And when it's a distribution of a sample mean, there is a new standard deviation that you need to use for your distribution and for your calculations. So the mean, so now we're interested in, I should go back and say, what is the question asking? The probability that their mean length is greater than 90.19 inches. So notice it's not the length of one board, it's the length of the mean from your sample. So the mean from a sample is x bar. So this question is asking, what's the probability that x bar is greater than 90.19? That's the thing we're trying to find. Okay, so now we need mu for x bar, which is still 90, but now we need sigma for x bar. And when you're dealing with a sample mean, this standard deviation is different. This is sigma divided by the square root of n. And that is 0.6 over square root of 39. And again, I'm going to break out my calculator, and I get 0.6 divided by square root of 39. So I'm going to type in like that, and there you go. Okay, so however you type it in, what you're getting is this. Yes, so 0.0961. Okay. So I like to use a bunch of extra decimals when I round stuff just in case, so I don't have any rounding error by the time I get to my final answer. All right. And again, we still know it's normal. So that's that given information, or that's that information that we just calculated, and now we draw the picture of the situation. So again, it's a normal distribution, 0 is in the middle for z, and now it's the distribution of not x, but x bar. So for x bar, we still have 90 in the middle, and the value of interest is still 90.19. So I mark that off, and it's still asking for greater than, so we shade to the right. And now we have some more calculations to do. So first we need the z-score. So as always, z equals, normally we'd say x minus mu over sigma, except we're not talking about x. We're talking about x bar. And we're not talking about sigma, we're talking about sigma x bar. Technically, we're talking about mu x bar, but it's the same value. So x bar is 90.19. Our mu is still 90, but the standard deviation is sigma x bar, and that's 0.0961. So we need to calculate that. Whip out the calculator. Let's see what we get. So I'm going to get 90.19 minus 90 all over 0.0961. Okay. So I'm getting 1.9771. A lot of places the standard is to put the z-score to 2 decimal places. That's usually fine. Like I said, I like to put extra decimals just in case. And so now from that, so we found the z-score, so we can fill that in. We climb the ladder one step, and next we can climb the ladder to the next step. So from the x-bar value, we calculate the z-score, and next from the z-score, we calculate the area or probability. And to do that, we need StatDisk. So with StatDisk, just from scratch, analysis, distribution, normal distribution, and I've got the z-score of 1.9771. Click evaluate, and there you go. It tells you everything. What I need is the area to the right, which is 0.0240. And that's the probability that we're looking for. That's the final answer. So to look back, in this problem, we were given that it's a normal distribution, and we were given a mean, and we were given a particular data value of interest. Now in part A, it was a single, it was from a single, in this case, a single board, so it was a single data value. In part B, it said it was a sample of 39 boards, meaning when I talk about 90.19, that is the mean from a sample, which is X bar. And so these part A and part B were both very similar, but that's the important difference. In part B, there was a sample, which gives you an N value, and that changes, the main change is how you calculate the standard deviation that you're going to need for your calculations. Altogether, there you go.